Hi, this is the third video in a sequence for ENV347, a tutorial on how to run the atomic absorption spectrophotometer in the Lake Champlain Research Institute Water Quality Lab. The AA we have is a PerkinElmer AA Analyst 400. This assumes that you've seen the first two videos on how to turn on the gas supply, the acetylene gas, the compressed air supply, and how to turn on the instrument itself. It also assumes that you've looked at the second video on how to create a standard, in this case for analyzing calcium. We'll start off by starting up the control software, WinLab 32 for AA. Be patient. The recording software competes on this old computer with the instrument control software, so at times things get a little slow. The AA software is just starting up. It's going to check. First thing it will do is establish communications with the instrument and go through a series of checks. So because we've had the instrument running previously, we'll go and look at the diagnostics menu first. Verify that everything is working. If we had just turned the instrument on from scratch, it would have gone through a self-check, and it's already done that. These are all check green. In the previous method I showed you, the previous video I showed you, if you get an interlock here, how to address that by putting water into the waste container U-tube. If these are all clean, you can, the auto sampler one will always show a red X because we're not using the auto sampler and it's not turned on. We can X out of there. The first thing we've got to do is get the instrument set up. Notice that it has a method that we previously developed, ENV347 for calcium. And we had previously put in standards in this method consisting of a blank. There's a method right there. So if it came up without a method, we could actually go into this method list of files and select a method and use it. So we'll click on OK there. And again, we have standards that we put into our method editor of a blank, 0.5 parts per million of calcium, 2 parts per million, and 5 parts per million, which is the top of the linear operating range. The first thing we'll do is to go to the lamps icon. And this is going to turn on and optimize our hollow cathode lamp. The lamp we're using is a calcium lamp. So it knows which lamps are in the instrument initially. So the lamp we want to use is the calcium magnesium lamp. So we'll click on that and turn that lamp on using this checkbox. And the calcium and magnesium lamp has both calcium and magnesium in it, so it's producing spectral lines appropriate for either one of those. But we're telling it here in the setup for that element that we're setting it up for calcium. So it's in the process now of turning the lamp on, setting the slit width, and optimizing the lamp. This will take a while, and eventually it knows which wavelength to go to. It's in the process of adjusting the grading and making sure that that's set correctly, and eventually it'll take us to 422.67 nanometers, and there it's set that right there. Next thing it'll do is it will orient the lamp to point it in exactly the right direction to give us the maximum amount of energy to the detector. The light beam in this case is the reference light beam that the mirrors directed around the flame, and we're just trying to get it to reach a maximum. So it's peaking on that wavelength right now. You can see the self-checks going on. And in the background you can hear various things being moved around, adjusting that lamp again to get that maximum energy. When it reaches that point, it'll display that energy. Typically we want to see an energy level of greater than 50, and for some lamps it's slightly lower than that. For calcium it's usually quite high. This will probably come up around 65 to 70 units here. And there we go. So we have a reading of 69, and it automatically sets that at the mid scale of your graph. And we can reset that if it's not. Again, if that were below 50, I would start to worry about if my lamp was getting too old. And typically what happens is lamps will use their high vacuum inside through very, very slow leakage through time. They usually last for many years. So with that, we can X out of the lamp setting. And then the next thing we'll do is to go to continuous right here. Now this will actually show the absorbance reading using the beam that doesn't. It's not the reference beam, but it's a sample beam that will go through the flame. And you can see right now it's set at about 0.024, and it's fairly constant. That's a very low absorbance level. Remember, absorbances typically max out at 2.5 or 3 absorbance units, so we're less than 1% of that for a background just in air. We can actually auto zero this. And now it subtracts out that 0.024 and sets it at 0.00. We should see fairly small variations around this line. Remember, this is the graph here is set at a very low level anyway, so our noise down here is probably less than 0.001 absorbance units. At this point, we would want to go through a series of routines that on the instrument itself that I can't show you. We would typically place a card in front of the light beam and make sure that the beam is just barely above the burner head, and that the burner head is not interfering with the beam. We would then turn on the flame and aspirate a standard and adjust the height of the burner head, the rotation of the burner head, and the orientation in and out of the light beam on a horizontal plane. And using all of those, we would try and maximize that absorbance. So with that, we need to go through and next thing is to turn on the flame. So we'll go up here to the flame icon. And it's telling you here that the safety interlocks are correct. If this is a red X, again, it probably indicates that your waste bottle does not have water in the U-tube, and again, you just have to take a squirt bottle and put it in there and jiggle the bottle until the electrical connection is made. But this looks pretty good. These flow settings are all automatic. The oxidant is air, and with that we just hit the on position. Sometimes it takes a few times, and you can hear the gas flowing right now, and the flame was just lit. Usually you wait a second and you'll see indication that your gas and your air are flowing correctly, and they should stay at those same settings. And you notice here, I'm going to take this window down to the lower right hand side of the screen. That way I can always keep a check on my gas flows. Notice here that during that setting, a little thing that creates an electric spark came out and impeded the light, so we got a little spike in the reading then. I'm going to go ahead and auto zero our graph. And at this point, I had the aspirating tube in air. I'll put it in our rinse water, which is just straight deionized water. And we'll wait for that to stabilize. And we'll auto zero that. Okay, so now we've auto zeroed on our blank water. We'll go ahead and put on our rinse water. We'll go ahead and put it in a zero blank solution, a zero blank. Now remember, if our blank would be different from our rinse water because it would have our lanthanum background correction solution in it. Oops, I'm sorry, I just put that in the wrong one. That's actually a sample that I wanted to analyze. So we'll put it back in the rinse water. We'll put it on our blank. We'll wait for it to stabilize. And we'll auto zero at that point. Okay, so now we're auto zeroed on our blank, our zero standard, and we're going to put it into a mid-range standard. In this case, it's going to be a 2 part per million calcium solution. And you notice that the absorbance goes up to 0.173. So at this point, I would go in and manually move the burner head. And I'm just going to do this and show you what happens. So I'm going to move the in and out control that moves it on an XY plane, not up and down. And as I do that, I was at 0.177, so we'll just go in one direction. And you can see it go down then to 0.127, etc. So we'll turn the opposite direction. Very slowly rotate the knob. And the knob I'm adjusting is right below the burner head. So now we're just about back up, and we'll just keep on going. We're 0.177, 0.179, that was our high, 0.180. So I'm still going in the same direction. And we can see it begin to go down. So what we'll do is we'll go back and try and peek in on that 0.180. And looks like it's about right there. Now we can do the same thing with the up and down knob and the rotational knob, and in each case maximize those so that we get the maximum absorbance, and this will get us the maximum sensitivity. And there are actually tricks where you can turn a flame around completely sideways, lessen your path length, and decrease the sensitivity of the analysis, but typically that's not done. Okay, so at that point we've set our flame conditions, and we're going to turn the continuous off. And at this point we're actually ready to begin our analysis. So we'll go to manual because we're not using the auto sampler. And again, I'm going to put the tube back into the rinse water after every sample. And now it's asking me to basically takes me through a set of things to feed in my standard. So the first thing I want to do is move from the rinse water to my blank, which I just did. And I'll tell it to analyze the blank. And again, this is going to measure, it's going to take 3 readings. Each reading is 3 seconds long. Again, each one of those 3-second readings consists of maybe 60 different individual 0.2-second readings. And it'll take an average of those and then an average of those 3. Here's the read delay. So now it's beginning the first sample, rep 1 of 3. Now it's doing rep 2 of 3. And it's then done with that one. So we'll take it out of the blank, and again, between each standard and sample, you always go back to the rinse water. This cleans off the outside of the aspirator tube, and also gets any material out of the burner head from the previous sample. So the next thing I'm going to do is to take the aspiration tube over in from a rinse water and put it into my lowest standard, 0.5 parts per million calcium, which it's calling for. And I'll tell it, it's telling me which one's there. I could actually change that if I wanted to. We'll tell it to analyze that standard. And again, our read delay. Beginning rep 2. And then finally rep 3. And at that point it's done. So again, back to the rinse container with our aspiration tube. It's now telling us to read the next sample. So we'll take it out of the rinse and into the 2 part per million solution. Tell it to analyze that standard. You notice here it's using the name of the standards that I gave it. Okay, so again, that finishes the 2. Now back to our rinse water. The next standard is our 5 milligram per liter. Put it into there. Click on Analyze Standard. Okay, it looks like it's finally measuring our 5 part per million standard. We had a little bit of a glitch there, but it finally caught up. I actually have a feeling the recording software might be interfering with this. It just printed out an analysis of the 3 standards. Everything looks fine. I'm going to bring up our standard curve here in a second. Okay, we're in the idle and ready to go for our next standard. I'm going to bring up our calibration curve. And you can see it's not the greatest looking one in the world, but it's pretty decent. It shows our blank down here, our 0.2 part per million, our 0.5 part per million, our 2 part per million, and then finally our 5 part per million standard. 0.5 maxes out at about 0.4 absorbance units. That's actually fairly low. Usually these things should be linear to a much higher absorbance reading than that. Anyway, at this point it's important to realize we can, when you see a screen like this that's blue, if you hit File, Print, and print that active window, it'll print your standard curve for you. It gives the R squared down there, the correlation coefficient 0.998. It's pretty decent for AA, but not the best in the world. And tell it which printer to print on. And that should then print out. So I can X out of here. And the next thing I'll do is again go back to our rinse water. Bring up our standard. And at this point we're here set to analyze our standard. We can actually, if we want to, give it a name. This is a diluted tap water, and that'll print out and we can then tell it to take it the aspiration tube over to that sample and click on Analyze Sample. So we're into our read delay. Measuring our first rep. Okay, and at that point we can, if we want to, we can go in and open up the info file on that. And I'm not seeing that there. We should have set up that sample information file in an earlier procedure. Anyway, so we could go on and measure multiple samples, and it'll print them out each time. Oh, yes, we can go up here to our results section, and if we look here, I'm going to maximize this screen. And at the top there, here's our first standard. Typical, the absorbance ratings were 0.021 for all three of the reps. It gives us a mean and a standard deviation for that standard. Here's standard 2, 0.053, that's 0.5 parts per million. Again, very good reproducibility, a mean of 0.053, standard deviation, and an RSD. If we go further down, excuse me, the 0.053 was our 0.5 parts per million standard. Here's our 2 part per million standard in the middle of the screen by 0.184. Again, fairly good reproducibility. Our highest standard at the bottom with a absorbance of 0.409. Okay, the results of our standard curve with the calibration data. And then finally, here's our analysis of the tap water. And it actually, using our standard curve, gives us the true concentration in parts per million. Looks like 3 values, 0.36, 0.352, 0.365. The mean is 3.359 parts per million. With a standard deviation of those three analyses is of 0.007 parts per million. So that's pretty good reproducibility. Again, we'd probably have to do that several times to get a true standard deviation. That's actually a standard deviation within the particular analysis. And with that, we can go up here, and since this is the active screen, we can print that out, the active window. and have our complete analysis done. Again, it'll keep a running log of these things. So if we had measured multiple samples, we could get a printout of the concentrations in the entire run. And with that, I think we're just about done. I'm going to minimize this screen and prepare to turn the instrument off. At this point, to turn the instrument off, put the aspiration tube back in the rinse water. Get clean water running through the burner head. Okay, the printer is finally printing out all of our results section. So we'll minimize the results screen. Turning the instrument off is fairly simple. You're going to want to pull after you put the aspirator tube into the rinse water, you're going to want to pull it out completely. Allow air to be pulled up into the tube. You'll hear a change in the pitch of the aspirator. And at this point, all you have to do is turn the flame off. And you'll see everything go to the off position. And you can now hear that the airflow stopped, and finally the switch indicates that everything is off. At this point, if you want to, you can bleed the gases, but you should not do that until you've completely turned all the tanks and the air supply off, because otherwise you'll just be running uncombusted gases through and creating a hazard. So you normally can just not worry about that at all. So we'll X out of everything. We can then get out of the software. It says, do you want to quit using the WinLab 32? You should do this you should let it go through its steps. So at this point we can actually save our sample info. And that would have saved the results of that entire run as a sample information file, an SIF file, and we presumably could bring that up at a later date and look at those results. So now it's asking me if I want to turn off the lamps. So we should always go through this power down sequence and let the instrument, the computer, shut everything off in sequence. So at that point, shutdown is complete. After you shut down the control interface, make absolutely certain that you go to the acetylene tank. Turn off the tank at the very top. Then downstream of the regulator, there's a knurled knob. Close that as well. Make sure you don't adjust the regulator. It's set for a specific gas pressure on the tank. Then go over and shut off the air supply next to the red filters on the wall, and then finally turn off the instrument itself using the switch in the lower right-hand portion of the instrument. And with that, you should be ready to do an analysis on the atomic absorption spectrophotometer.